Imagine being frozen solid. Your blood turns to ice. Your heart stops beating. You stop breathing. For most animals, this would mean death. But some remarkable creatures can survive even this seemingly impossible feat. They freeze solid in winter, only to thaw back to life when spring arrives. This incredible ability, called cryobiosis, is a testament to the astonishing diversity and resilience of life on Earth. Animals like wood frogs, Arctic ground squirrels, and certain species of turtles can withstand freezing temperatures that would be lethal to most other organisms. They have evolved unique physiological adaptations that allow them to endure the formation of ice crystals within their bodies, a process that would typically be fatal. Understanding how these animals survive such extreme conditions has captivated scientists for decades and holds significant potential for various fields, including medicine and cryopreservation. The key to surviving freezing lies in controlling where ice forms. When ice crystals form within cells, they damage delicate cell structures, leading to cell death. Cryogenic animals have evolved mechanisms to prevent this. They accumulate high concentrations of cryoprotectants, such as glucose and urea, in their vital organs. Cryoprotectants act like antifreeze, lowering the freezing point of water in cells and preventing the formation of large damaging ice crystals. Instead, ice forms in extracellular spaces, outside the cells, where it causes less harm. Some species even have ice nucleating proteins that encourage controlled ice formation in these less critical areas. These adaptations, combined with a dramatic slowing of metabolic processes, allow these animals to enter a state of suspended animation, where they can survive for weeks or even months in a frozen state. The wood frog, a small amphibian found in North America, is a champion of freeze tolerance. As winter approaches, the wood frog prepares for its frozen ordeal. It accumulates glucose in its liver, protecting its organs from damage. As the frog freezes, its heart stops and it appears lifeless. Yet a remarkable transformation is taking place. When spring arrives, the frog thaws and comes back to life. Its heart restarts and it hops around as if nothing happened. Beyond the frog, other cryogenic champions. The wood frog is not alone in its ability to survive freezing. Arctic ground squirrels can lower their body temperatures below freezing. They survive by supercooling. Painted turtle hatchlings can withstand freezing temperatures. They use cryoprotectants and tolerate low oxygen. Many animals have evolved to survive freezing. Each species has unique adaptations. Studying these adaptations holds potential for medicine and cryopreservation. Lessons from the frozen, potential for medicine and beyond. The remarkable abilities of cryogenic animals have sparked the imagination of scientists and science fiction writers alike. Understanding how these animals survive freezing could revolutionize human medicine. Cryopreservation is vital for organ transplantation and storing reproductive cells. Current techniques often result in cell damage. Studying wood frogs could improve cryopreservation methods. Imagine storing organs indefinitely, eliminating donor shortages. or repairing damaged tissues with cryopreserved cells. The possibilities are vast and exciting. This research also impacts space exploration. It could help us find life on other planets and enable long-duration space travel. These animals' ability to freeze and thaw is a testament to natural selection. The natural world holds wonders that could solve humanity's greatest challenges. Stay curious and explore more with Brain Bites. Subscribe now for more fascinating insights.